y equal to, the logistic line equation is y equal to e power beta naught plus beta 1 x1 divided by 1 plus e power beta naught plus beta 1 x1 is the simple logistic regression line equation where you have only one variable that is predicting the target variable y. But in real life, we know that it's not just one variable that will impact the target variable. A customer buying or not buying, a customer responding or not responding, they will not simply depend on one variable. They will depend on several variables. My variables, predictor variables will be x1, x2, and so on, xk. Can you tell me what is the equation for logistic regression where multiple variables are present, multiple predictor variables are there? What I should do? It is very similar to our previous expansion of linear regression line. Instead of saying beta naught plus beta 1 x1, you will say plus beta 2 x2 plus beta 3 x3 plus and so on, divided by e power beta naught plus beta 1 x1 plus beta 2 x2 plus beta 3 x3 and so on. That is the multiple logistic regression line. The multiple logistic regression line is a extension of a simple logistic regression line where we are using multiple variables for prediction. And in reality, we will be building multiple logistic regression lines. It's not the simple logistic regression line that we will be. Let us build a multiple logistic regression line. Let us take this case study. There is something called fiber bits data. This is coming from a particular company. I'll explain you what is the real business objective here and what we need to do. What are each and every variable, we'll go through them one by one. First, go back to your code, import this data set, be ready with the column names. And once you're ready with the column names, let me know. I'll explain you column by column, one by one, and I'll also explain you what is the objective here. Let me know once you're ready with the column names. Are you ready? Done? All right. Now, listen to me carefully. This data set has been shared by one internet service provider company. What they want to do is they have 2 years data. In last 2 years, some of the customers are inactive. Inactive means they have left their network. That means they attrited. They discontinued the services. Some of the customers are active, which means they are still using our network. They are using our services. That is what happened in 2 years. Now we have a set of customers in a particular region or somewhere. What this company wants to do is they want to predict based on this data. They want to build a model, and this model should be able to predict who will be inactive, who is going to be inactive, who is going to be attrited. You know, attrition means leaving. Who is going to be attrited, who is not going to be attrited. So the model should take customer one and his details and tell me whether he is going to leave or whether he is going to stay back. This should be the prediction from the model. And what is the data set that is input for the model? You should take this historical data, learn the patterns, create the formula. Once in that formula, if you substitute all these values, it should be able to predict whether a customer will leave my network or not, whether he will stay back or leave. Now think from the business point of view, all of you. What is the need of such model? Can you think? What is the need of such model? What is the need of, what is the advantage if I get to know that this customer is going to leave? What can I do from the business point of view? Tell me. You can run, you can provide better offers, you can do retention strategies. Perfect. That's what I'm looking for. Whenever you are saying offers and all that, if a customer is going to leave, you are going to apply retention strategies, isn't it? Retention strategies, customer retention strategies. Do you know companies believe that retaining a customer is easier than getting a new customer? Do you know that? Getting a new customer is double hard or thrice as much as retaining the old customers. So companies definitely want to retain the old customers, isn't it? Who's the customer who is going to leave? If I get to know, then I can run some retention strategies, a simple retention strategy that every company follows. Even that retention strategy might have been applied on you as well. Wave off, they will say. Have you ever heard this word? Wave off, 1 month bill waived off, late payment waived off, wave off, wave off. That means जो भी किया जो हो गया, come back, don't worry, we are there types, isn't it? Wave off is one of the retention strategy. Have you ever observed, maybe next time you observe, suddenly you stopped using an app, suddenly you stopped one food delivery app or Ola or Uber or some service, or maybe a particular bank transaction you stopped, or a particular mobile network you stopped, then you will be getting a message. How are they sending you the message? Don't do you think the same message is sent to everyone who is in their customer list, or they are sending specifically to you? So what they did, they applied this model. This is known as attrition model. Attrition models. What are attrition models? The models that will predict whether the customer will attrite or not. If they predict that you are going to leave, you will be given retention strategies. Remember, every company in this world which is dealing with end customers, retail customers, they have to build these attrition models. You cannot run away with these attrition models. One of the most widely used models. Every company, from small to large companies. Now, what if the customer is going to stay back? What will you do as a company? Think from the business point of view. If there is a customer, there is a high chance for him to be loyal. He will not leave. That's what your model has predicted. He is going to stay back. No attrition for this customer. Very low probability for attrition. What can you do with these customers? Think from the business point of view. Don't tell me that we don't do anything. You have to increase the revenue from him. Yeah, how do you do that? How do you do that? What is a technical term for it? There's a customer who is likely to stay back. Yeah, if you give offers, gaya. You cannot give offers. If you are thinking I'll give offers to these guys also, loyal customers go be offer diya, and then the customers who are leaving the company, they are also giving offers, then we will not be able to do business. Offers you cannot give to these guys. No, 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 no. No offers. No offers to these guys. You have to do, yeah, I think I got one or two answers correctly. You have to do cross selling and upselling. Have you ever heard of it? Cross selling and upselling, isn't it? Are you having one particular product? That means, are you having a savings bank account with us? Open a FD. Take this loan from us. Take that. Take this credit card from us, etc., etc. Cross selling means if you have product A, if you have service A, I'll try to give you B, C, D, etc., etc., so that I can increase the revenue from you. Yes or no? What is upselling then? Tell me. What is the difference between cross selling and upselling? What is upselling then? Cross selling means giving a different product. If you have product A, then giving a different product is cross selling. Increasing the usage. If you have product A, giving more of A, take one more A. That means if you have one connection, let us suppose if you have Reliance Geo connection for mobile, maybe take Geo Fiber, Geo this, Geo that, and all that, are more features of the same product or value added product, something like that. You add the same product twice or thrice and maybe give try to increase the revenue like that. So we don't give offers, by the way. Honestly, we don't give offers to the loyal customers. Offers are only for those customers who are likely to leave, because once the customer is in our basket, we have to gain maximum out of it. That is the overall business. But let us see what is the issue here. Here we have the target variable active cust, which takes two values, 1 and 0. 1 means the customer is active, 0 means he is not active. Not active means he left the network already. Okay, he attrited. Active means he is still using the network. We need to predict that. Let us see what are the parameters that are used for prediction. All of you go back to the code and let us see the parameters. The parameters, the target variable is active cast, and what are we using? income, months on network. Do you think months on network, do you understand what is months on network? Do you think months on network has an impact on attrition? Months on network, I think a customer is like with us from long duration, I think he will have lesser chance for attrition. Like those who are recently come in, they are might be trying us, they are more likely to, they are not yet used to our services, they may leave. But I don't know, like model will tell us finally, but we can consider this from the business point of view. Number of complaints, of course, number of complaints has an impact on attrition. Number of plan changes. Hey, what do you mean by number of plan changes? How does that impact attrition? Number of plan changes. A customer is frequently changing his plans, this plan to that plan to this plan. Maybe that is an indirect indication to us that the customer is not happy with our product. That's why he's trying different plans. Maybe that may be an indication. Whether the customer is relocated or not, since this is internet service provider, customer relocating is also a big deal. Monthly bill, technical issues per month, you're promising a speed internet service right now. Speed also a big thing. In fact, companies really push forward speed related ads also. Speed test results, like you promised a speed, whether you can reach out to it or not. So the output is target variable is 0 and 1. These are all the input variables. We will build the logistic regression line. Why are we going for logistic line? Can somebody tell me why are we considering even logistic regression line here? What is the reason? The reason is straightforward. The output is either 1 or 0. It's a classification problem. It's a it's not a simple linear regression problem. We'll go for logistic regression line. So what is the code for it? Let me explain you the code for multiple logistic regression line. The code is, as usual, from sklearn, import logistic regression model equal to logistic regression. This is configuration. Model.fit dataset is fiber here. X1 plus X2 plus X3 plus X4 plus X5 plus X6 plus X7, etc., etc. All the X variables, check this out. All the X variables, X1 plus X2 plus X3 plus all the X variables. And then finally, comma, this is done. Like the double list is done here. Check this out. List, within that there is a plus sign, everything is given, all the X variables. And then the final target variable is active cast. The final one is the target variable. So you have X1, X2, X3, and so on, etc., etc. Finally, the target variable. Okay. At the end of this, usually if we were using some other package like stats models, we used to write logistic dot summary. But unfortunately, there is no such summary here. Manually, we have to extract all these values, like the way we have in linear regression, one by one, step by step process. Here also we have to follow step by step process, but that will be manual. I'll explain you one by one. First of all, let us go ahead, build the model. This model result, you will not be able to interpret anything out of this result. Maximum what we will get is just the function and all that, and then we can get the intercept and the output values, the coefficient values. But that is not what we immediately look at. What we want is how good is the model, what are the impactful variables, are there any multicollinearity, those kind of issues we want to extract out of this output. But there is no summary. So we will see how to extract those values. First of all, what I want you to do is build the model, be ready with the model. Once the model is in front of you, that means if this code is working perfectly, let me know. Then we will proceed further with goodness of it and all that. Send me a message once the model is in front of you.